Hello everyone. In this content, we are trying to follow the book Spatial Data Science with applications in R. This is a wonderful book indeed, and we are trying to follow the very first chapter, and the goal is to follow each and every chapter in the upcoming days. And what we will try to do is we will try to summarize the chapter as much as possible, but the things might not be that easy to grab or too easy to summarize in just one video. So we will be to go through the chapter, and we will try to summarize as much as we can. And here is the very first chapter. And my objective of following this book is I want to learn to make maps in R. I think that's okay to say. And of course I want to learn R and some spatial analysis. And I will want to learn about the R packages. So these are some of my objectives of following this book. So let's start the very first chapter. So the first chapter starts with some codes here, and let us run this, and we get something like this. And from this chart here, we get the polygon. So we can see there is some structure outlined. We have some legends at the very bottom with different color levels and some values indicated to each and every color, or that's what you can see. And there are some backgrounds, and you can see the lines are curved in some way. And then we have the axis, that is the longitude and latitudes. And this is it. This is the very first map this book tries to teach us. And what we can see here is we have loaded the very first two packages. The first one is tidyverse and the second one is SF package. From that package there is this function called system.file, and there is something, this package within this library. Within this package SF, there is something, this package, and this has been stored to the ANSI variable. So we are reading this by read_sf, and this has been transformed by st_transform to some coordinate reference system and stored at some variable again. And by selecting something here, we're selecting something, and we are doing this plot, and we're specifying axis as true and this critical as true. So this is the very first code this book teaches us. But this first chapter is not about the course. It's about the overview of the process. So we learn about the polygons, legends, backgrounds, and axes. So what this is being shown here in the plot section. So to define the polygons are the sequences of points when the points are connected to each other, and when the points are connected in such a way that all the points are connected and make some kind of structure or gives some kind of a diagram that's called a polygon. So they are connected by straight lines. And in this case, this BIR74 is the numeric variable, and each variable has been represented with some color inside this polygon, or inside this geometry, or inside this feature. So this BIR74 is the path counts over the region. And here we can print the different columns, or this data can be printed So what this shows us is that it contains 100 features. That means 100 rows, if I'm not wrong. Yes, there are 97 more rows, and we are being shown with only 3 rows because we're specifying n equal to 3. And the other thing is it has the geometry type as multi-polygon. Before that, we need to know that this is simple feature collection. And there we have the dimension x, y. This is because we have the x, some 2 different coordinates. And then we have this bounding box. And then we have this coordinate reference system, something called NAD27. And after that, the book tries to plot the facet plots, something like that. And here it is. This has printed some 2 plots showing the variable baud charts, baud counts from the year 1974 to 1978 and from 1979 to 1984. And we can here dive deep into this code here, trying to understand what's going inside. And other thing is there is something also here. So we can also do some of this interactive map here with the legends being shown. And there is the concept of different datums. So for example, in the first chapter there is something called WGS84 and NAD27. So the concept of datum is that how the shape of the earth is considered and how the things are attached to the earth. So basically each datum has its own way of representing the planet Earth or the shape of the earth. And for understanding the vector, we have understanding vector and raster. They are the 2 different data. The polygons, points, and lines. And the raster are somewhat the regular representation within some square-shaped pixels. And the book shows us something. Let us run this. So the book gives us the example of the vector and raster data. So here we have the raster data being represented with numbers inside these square boxes and with different values. And the vector data set as points are being overlaid and the raster data set. So the operations between a vector and raster data can be combined. For example, there is this way of doing things, just finding the mean and the buffer. And we can convert the raster pixels into point values and the converting of raster pixels into small polygons, or we can also merge polygons with identical values. So these are some of the things we can do, and I hope the following chapters will show us these ways. And this is in the both ways. And there are something called as the raster types. So what it means is that not always the squares in the square or the square shapes are equal in the raster data. For example, the first one here is the regular, but the other types or other shapes or square shapes are somewhat different, and they are not exactly in the same way. as the regular ones. So that's the thing this course tries to say. But again, if we jump in this code, there's so much things here, and we can just go line by line what each line is doing. And there are something called the time series, because the things are also represented with this time thing, and this results in something called the data cube, and the cube something referring to the arrays with any numbers of dimensions. And then the other things to understand is that this things that we are doing, the packages are dependent on other packages. So these are GDL, I don't know how to pronounce this, project or GUS and SD geometry, NetCDF, and other packages. And the 1.8 is about the exercise. There are 4 questions. And to summarize this chapter, so the book opens with the course, and we can go really into the course and see what it is trying to do. And it gives the overview of the spatial data science. And what I liked is that as soon as we opened the very first chapter, we learned how to make the very first map. So I hope this was helpful. Thank you for watching.